In this video, we're gonna do a practice exercise on a passive filter. We're gonna start with a design of that circuit and then simulate it using Multisim Live. Here we're given a problem, a design problem that says design a passive RC low pass filter with the following properties. So we're given certain constraints on the design. We're left out with remaining properties that we need to find out on our own. We're given the cutoff frequency, denoted as Fc or F cutoff, which is equal to 1 kilohertz, and we're also given the value of the capacitor, which is 1 microfarad. We learned two types of RC passive filters, the low pass and high pass passive RC circuits. We need to figure out which one between the two is the right one, or is the low pass filter circuit that we're looking for. If you remember, we mentioned in the lab one of the physical properties of the capacitor is that it acts as an open circuit in low frequency signals, which means that the circuit on the left-hand side is the correct circuit for our purpose. So the circuit on the left-hand side is the correct circuit for a passive RC low pass circuit. So now we have the correct design or the correct circuit schematic. We just need to find out the parameters that are missing, or the values of the parameter that is missing. We have already the capacitor. We just need to find out the value of the resistor. We learned one formula that relates the parameters of an RC passive filter, and the formula says that R is equal to 1 over 2 pi the cutoff frequency times the capacitance. So if we substitute or plug in the values, we're going to find out that the value of R that will give us this specific filter with these properties is equal to 159 ohms. So now we have the complete design. The only thing left is to move on to Multisim and simulate the circuit. We have R is equal to 159 ohms. The capacitor is equal to 1 microfarad, and for Vn, we need to assume that we have to use an AC voltage, which makes sense because we're designing a filter that filters out certain frequency ranges, which means that in order for the circuit to be useful, Vn, or the input voltage, must be an AC signal or a signal that has a frequency. And for the simulation type or the analysis that we're going to use must be AC sweep, because we learned that with AC sweep, you'll be able to plot the frequency response of a filter, or you'll be able to plot the magnitude of the output voltage as a function of frequency. A tip on one way to verify that your design is correct in Multisim is to measure V out at the cutoff frequency. So find where the cutoff frequency is and measure V out in the plot. You should be able to find that in decibel scale, V out must be equal to -3 decibels. Or if you're working under linear scale, that means V out must be equal to V out max over the square root of 2, or Vn over the square root of 2. That is if you're working under the linear scale. But usually when you're plotting the frequency response, usually we deal with decibel scale. So keep that in mind when you want to verify the accuracy of your circuit once you move on to simulation. Probably you're going to use the linear scale formula when you're dealing with actual practical work with the lab itself. And here we're transforming to Multisim Live to simulate the circuit. First, we're placing the components that we need. We're starting with the resistor. Here I'm not, sometimes I don't change the parameter values directly. It's up to you whether you want to place equipment or components, and then change their values, and labels or right away, or complete the circuit first and then set the values for each component. It is up to you, but make sure that you do the connections right and then you revise each component and make sure that it has the correct value. So for an RC filter, the circuit is very simple. You need a resistor, capacitor, and an input voltage. But when you're simulating the circuit, it is important that you place a reference point, in this case, it is the ground. And finally, we're gonna place a probe at the out. So we'll use this probe, the voltage probe, double click it to make sure that you give it a proper name or a meaningful name. I'll label it V out. Here I left Vn as it is. If you want, you could also change the label of Vn so it would be of V1, so it would be Vn. I'm adjusting the value of the resistor to 159 ohms. And finally, I'm choosing AC sweep under the list of the simulation options. And then finally, you need to click play. If you want, you could start with the split, so it will split the screen into half. This way, you'll be able to see the circuit on the left-hand side and the simulation result on the right-hand side. The simulation tool have plotted for us both the magnitude and the phase. So notice that you'll be able to change how many points you want to plot, the ranges of the frequency, and the ranges of the magnitude. You'll be able to adjust that for the settings of the simulation. Here I'm first changing the scale of the out, the vertical scale to decibel. Negative 140 is too much. I need a proper range, so I'll be able to find the -3 decibel point, which is also another name for the cutoff frequency. I started with -14, and then you can also play with it. You can press zoom out, auto fit magnitude, just to make sure that you get the hang of it as a tool. This is just to display. This is all for display purposes. It's not going to change anything in the simulation itself. So finally, I'm changing the frequency range from 1 hertz to 4 kilohertz because my cutoff frequency is 1 kilohertz, so that will fit within the range. You have also cursors. Here I'm looking into the y-axis cursor, so the values displayed will be of the magnitude and decibel. If you want to change, you can also move the cursors up and down. You have 2 of them. Sometimes in some circuits, depending on the application, you'll only need one of the cursors. You can leave the other one there anywhere and then just read the values from cursor 1. Here it's changing. If you look at the bottom left corner of the screen, the simulation screen, I'm moving cursor 1 at -3 decibels approximately. If you notice, the corresponding x-axis or x value for that particular point is 1 kilohertz, which is exactly the cutoff frequency for my design. Here I'm disabling the phase, so I'm only looking at the magnitude. You can always start by that. You don't have to wait till the end. And again, I'm pointing at the -3 decibel point. Another way to look at it is to change the type of the cursor to x-axis. So go to cursors, choose x-axis. Now you can move the cursor directly to the cutoff frequency that you know, which is 1 kilohertz in this case. And now you need to read the value of the magnitude, which is here in this case -3.09 decibel. So both points are now located next to each other. You'll be able to tell whether your circuit design is correct or not, simply by looking at these 2 values. This will be it. So that's sufficient for your screenshot for the simulation and design of a passive RC filter. Thank you for watching and good luck.